The metals, the principle of metal shearing using punch and die as shown in this diagram. यहाँ पर आप ले सकते हैं there are a diagram of punch and die assembly, and this is the shearing operation. This is the diagram for rupture. So then when the punch is forced, this was punch, there are direction of force. Punch, when the punch is forced down into the sheet metal and the punch first draws the stock in the circular bend and over the cutting edge. So there are arrangement of a cutting edges and the grain elongates near the cutting edge A of the punch and the die corner D. This is the position of A and there are a point D. The point A, cutting edge A and of the punch, or D is the die corner capital D. Then as the punch descends further, this local deformation increase, and when local strain in the surface fibers reach the limiting value for the work material and fibers rupture. This the condition is rupture. There was slag and the crack starts just ahead of the punch corner, but with the advancement of the punch and the thin inner fibers also get ruptured and the crack start advancing from both sides. And figure A, that is searing operation, figure B, that is a rupture, and the crack starts just ahead of the punch corner, but with the advancement of the punch and the inner fibers also get ruptured and the crack starts advancing from both the sides. There are diagram for indication for both the sides. And ideal cutting conditions, the punch may be penetrate the metal up to one third of the depth before fracture take place. तो यहाँ पर प्रोवाइड है क्लियरेंस, यहाँ पर देख सकते हैं दिस वन इज द डायग्राम फॉर क्लियरेंस, दिस इज द करेक्ट क्लियरेंस, दिस वन इज द टू लिटिल क्लियरेंस एंड दिस वन इज द टू मच क्लियरेंस. क्लियरेंस यहाँ पे देख सकते हैं देयर आर करेक्ट क्लियरेंस, लिटिल क्लियरेंस एंड टू मच क्लियरेंस. क्लियरेंस को इंडिकेशन किया जा रहा है यहाँ पर कैपिटल सी के थ्रू. तो what is the principle of metal shearing? In this principle of metal shearing हमने यहाँ पे देखा कि it is the if the clearance between the die and the punch is correct, if the clearance between the die and the punch is correct, the crack started at the two ends spread towards each other until they meet, causing separation with a clean edge, and the amount of clearance depends upon the thickness of the sheet and ductility of the work material. For steel with clearance varies from 5 to 8% of the thickness of the sheet, and larger clearance up to 10% are required for aluminum. This is the data. Larger clearance up to 10% for aluminum, and steel their clearance varies between 5 to 8% of the thickness of the sheet, and larger clearance up to 10% of the required for aluminum. Ductile materials requires large penetration of punch required. Then in this year, ductile materials require large penetration of the punch compared to the harder materials, and the effect of clearance on the shearing action as shown फिगर, दैट इज हमने यहाँ पे देखा था करेक्ट क्लियरेंस डायग्राम, that is the influence of clearance. The effect of clearance on the shearing action as shown figure. If the clearance between the punch and the die is too larger or too small, the cracks started at the punch and the die do not meet as shown figure. Additional bands of metal must be sheared in such cases to complete the separation, and this leads to higher cutting forces and cut edges are generally not smooth. So what is the clearance value? In there are excessive clearance also cause a large radius to be formed. The and corners of the slug and workpiece. Medium carbon steel, stainless steel, brass, copper, bronze, aluminum, aluminum alloy. There are values of shear strength as per, and clearance value normally shows use per side in this table. Clearance value, this is the clearance value. Clearance value normally used for punching. अगर एल्युमिनियम लेस देन 1 mm थिकनेस है तो क्लियरेंस परसेंटेज फॉर स्टॉक इज 2 to 3%, एंड एल्युमिनियम मोर देन 1 mm थिकनेस है तो 3 to 5 mm, कॉपर लाइन है तो 2 से 6, लो कार्बन स्टील है 2 से 3, हार्ड स्टील है 3 to 5, स्टेनलेस स्टील इज 4 to 8. This is the clearance percent of stock thickness. Then the actual value used for normally nearer the lower end of the range, given above for round workpiece and near the upper end for the other contours. So we see this in the reverse assembly metal shearing process. In the metal shearing process, we see the shearing operation, rupture diagram. We see the correct clearance, too little clearance and too much clearance, and we discuss effect of correct clearance, too little clearance and too much clearance. There was a formula to find out the clearance. C is equal to 0.0022 T square root of Fs, जहाँ पर C हमारा clearance in mm each side और T हमारा sheet thickness और Fs हमारा शो करता था shear strength of the material. Then we studied out the table and we studied the clearance normally used for punching. If the aluminum less than 1 mm thickness, the clearance percentage is 2 to 3. Aluminum more than 1 mm thickness is 3 to 5. Copper alloy 2 to 6. Low carbon steel 2 to 3. Hard steel 2 to 5. And stainless steel is 4 to 8.